All right, so we're doing our last section tonight. So this last bit is about writing polynomial equations given roots. And so we've kind of done a little bit of this already, but we're also going to be looking at how to write the equation from a graph, also how we can account for multiple solutions and get just one. So one of the things we want to remember is that all of our equations, we can write them as y equals a times our roots, depending on how many we have. So if we have a quadratic, if we have a cubic, this pen's officially dead. Okay, and this can continue for however many degrees we are. But we should remember that we should have as many factors as our degree is supposed to be. So if we have a fourth degree, we should have 4 factors. We also have to account for a potential GCF, that's a constant. And we haven't really done that yet. And so that's one of the things we're going to look at today, is how to double check that our constant is correct. Excuse me. So we're going to go through tonight two examples, and then there'll be 2 more that we'll go over in class before you guys work on a worksheet about writing polynomial equations. So this first one that we're going to go through, our directions are going to say write a 4th degree equation with roots one half that has a multiplicity of 2 and 6 that has a multiplicity of 2 and a y-intercept equal or of -4. So this is everything we know about the equation that we want to write. So with what we've done before in writing our equations, or in writing equations, we know that we can take each factor that's given to us and write it as x minus 1/2 and x minus 6. Okay, those are the factors that were given to us, so we can work backwards to say if x is equal to 1/2, then x minus 1/2 equals 0. So we're working our way backwards. The multiplicity of 2 means we got this one twice. So we're going to have a squared on it. Same thing with the 6. So what we want to check now is, do we have enough factors? So if we were trying to write a 4th degree, if I multiplied this out, would I get an exponent of 4? The answer is yes, because 2 plus 2 is 4. So you want to just double check that to make sure you've accounted for multiplicity and that you've hit all your factors that you need to hit. Now the one thing we're not sure about is a. Because a, we don't know if this polynomial had a GCF constant that was taken out or not. So how to figure out a is we use this y-intercept. So our y-intercept is 0, -4. So if this is x and this is y, we can plug into our equation by changing this to f of x or y. We can plug in x and y to solve for a. So I know that 0 is x, and I know that y has to equal -4. And so we're going to solve this for a to see what constant our a might be. Now if we get 1, awesome, it means we didn't have a GCF. But if we get something else, then that means we had a GCF that we factored out. So here, order of operations, -1/2 squared, -6 squared. We'll get +1/4 after we square it, and +36. 1/4 times 36 is 9, so we get 9a equals -4. So a would equal negative 4 over 9. So what that means is that our final equation is going to be negative 4 over 9, so our a, times x minus 1/2 squared times x minus 6 squared equals f of x. That is your 4th degree polynomial that has 1/2 as a solution with a multiplicity of 2, that has 6 as a solution with a multiplicity of 2, and it has the y-intercept of 0, negative 4. So we've done, like I said, we have done these a little bit before, but we never had to account for that constant. So this is going over how we write them and account for the constant. Okay, the second one I wanted to do with you today is pretty similar. We're sticking with a 4th degree polynomial. So that means, again, we want to make sure that when we put all of our exponents in together, that they come out to 4, because that's how we'll get 4th degree. So we'll write a 4th degree equation with roots of 3 with a multiplicity of 2, 1/2, negative 3, and f of 1 equals 2. So again, I'm going to start it by looking at how we did it before. I know that if I have 3 as a root, then that means I had x minus 3 in parentheses. The multiplicity of 2 tells me that's going to come out twice, so I'm going to have it squared. 1/2 means I'll have x, whoops, not an equals. Means I'll have x minus 1/2. Negative 3 means I'll have an x plus 1, or sorry, x plus 3. I put my a in front just to make sure that I've got that okay. So here would be a good start to your function. So for this one, we just now need to figure out a, and we're going to use that f of 1 equals 2 statement. So if we remember how to read our function notation, this means when x is 1, y is 2. So just like the y-intercept, we're given an ordered pair, it's just not the y-intercept. So we can plug in the ordered pair to help us find a. So let's see, x is 1, so 1 minus 3, 1 minus 1/2, 1 plus 3 equals 2. So I made my a a little long there, it looks a little 9-ish, so I'll make sure I do a. Here we'll have negative 2 squared, 1/2, 4 equals 2. So negative 2 squared would give me a 4 times 1/2 times 4 equals 2. So if I multiply 4 times 4, that's 16. 16 times 1/2 is 8. So a will equal 1 over 4. So my a is going to be 1 over 4. So then I can come to my equation. F of x will equal my a, 1/4, times x minus 3 squared times x minus 1/2 times x plus 3. Now, one thing that you can do whenever you have a fraction like 1/2, if you would like, you could write your 1/2 instead of doing x minus 1/2. It's the same as if you were to do 2x minus 1. So bring the 2 as the coefficient of x. These are the same answer, because if you were to solve this, you would still get 1/2 as your root by adding 1 and then dividing by 2. Some people like to write it this way so their answer doesn't have any fractions. Some people don't really care and will just leave it as the minus 1/2 and deal with the fractions. I will take either one. So if you like no fractions, then when you have a fraction like this, you just put the denominator in front of x and write your polynomial. Okay, in class we're going to do one more like this, and then we're also going to do one where I'm going to give you the graph, and from the graph you are going to decide all the same information. What are the roots? What is the multiplicity? What other points do you absolutely know for sure that you can use to help you find A? So we're going to, instead of being given it listed like this one or the one before, we're going to have to read it from the graph. So those are the two I want to do with you in class, and that's the last bit of this unit.